Okay, then let's talk about graph neural networks and graph embedding problems, and why we need to study these problems and how to learn the embeddings of the graph data inputs. So you may wonder why we have to study the graphs in this section with deep learning. The main reason is because we have a lot of graphs in the real world. In this page, we show you with some examples of the graphs data we have in the real world. So I assume many of you are playing with the social networks, right? I mean, you can socialize with friends in Facebook, in Instagram, also in like Snapchat, for example. You can send messages, share photos, or also do some other activity together, I mean, in the online social networks. Also, right now, the Facebook is changing to Meta, I mean, the metaverse, right? And they try to create a virtual online world, I mean, which can allow the people to interact with each other or via the technology of the VR and AI, right? So, I mean, by this kind of social networks, we can socialize with each other. At the same time, the data of the social networks can also be represented as a graph as well. Now, if we treat each user in the online social network as a node and their interaction or their social connection as edges, then we can transform this online social network into a graph structure data like this one, right? And besides this online social network, some other data we study in like bioinformatics, right, can also be represented as graphs as well, like the molecular graph and the protein graphs. So normally given a molecule, I mean, we can represent its structure as a graph as well. We know these atoms as well the bond connecting the atoms. If we treat the atom as a node and the bond among different atoms as edges, then we can transform or we can define this molecule as a molecular graph as shown here. Right? It is a natural graph structure. It will be similar for proteins. I mean, for the protein, it is also a molecule, right? And we can also represent it as a molecular graph or we define it as a protein graph as shown here. So this kind of definition of the graph structure for the molecules as well as proteins, then we can utilize the graph representation learning and the graph neural network models to deal with the problems as we study in the bioinformatics. And besides this, in the neuroscience studies, I mean, when we deal with the brains, for example, we can also define its corresponding brain graph as well. We know, I mean, we can do a scanning of the brain, I mean, this organ inside our head, right, with some tools, with some techniques like CT or fMRI. So by the scanning results, we can divide the brain into different regions. And if we treat each region as a node, I mean, of the brain regions, then, I mean, also the connection or the correlation among the activity of different regions as edges, then we can define this brain, this organ, I mean, scanning data as a brain graph as well. This brain graph can illustrate the activities of different regions inside our head and also can illustrate some functional correlation among each other as well. It provides it as a very powerful tool to study some neuroscience problems with graph neural network models and graph learning techniques. So before we have been discussing the text data as well as the image data, right? So at the same time, I mean, for the text and the images, we can also transform this kind of data into a graph as well. Now, given a set of documents, I mean, based on the document contents as well as some entities and the relationship among the entities mentioned in the text data, then we can transform the documents into a knowledge graph as well. We have different entities as well as different correlation or relationship among different entities as we show here. We can define the data like this as a knowledge graph, right? So in this way, by transforming the text or documents into the knowledge graph, it can transform its unstructured data into a structured data like knowledge graph as shown here, right? It may make many of the problem, I mean, studies much easier actually, I mean, based on the structured data like the knowledge graph. We can extract many of the patterns from the data much easier than from the text data we named before. It will be similar for the computer vision. Now, given an input image, normally this image can contain many rich information, right, as we show here. Now here in this image, we have two persons, they're riding a bicycle, although they're holding the hands with each other. So, I mean, if we see the image like this, normally this image will be very hard for the model to deal with. However, if we are able to recognize the person as well as information inside the image, then we can transform this image into a single graph instead. Now we have a person, this man is riding a bicycle, he's also wearing a jacket, his hand is holding the hand of the lady, this lady is also riding a bicycle as well. So you can see, I mean, compared with this image, this single graph can deliver the information much more precisely or correctly as we see here, right? So this is other examples of the graph data we have in the real world. Of course, we have some more examples of graph data as we are studying in the real world. That's the reason why we have to consider to study the graph neural networks and the graph learning problems in this section. Okay, so we also provide you with some background knowledge in this page. How to represent a graph. I assume you have learned this before already in your discrete mathematics courses, right? So formally, a graph can be represented as a pair. We can represent a graph as G, covering both the node set V as well as edges or the link set E as shown here. So a link in the graph can be represented as a pair as well as Vi and Vj, where the Vi and Vj are the nodes inside the node set V in the graph. So given the graph, we can also represent its structure as a adjacency matrix as well. This matrix will be binary. And if an entry in the matrix is value 1, has value 1, it denotes this edge, connecting the two entries or the nodes exist inside the link set. I assume you know this already, right, in your previous courses. Okay, then in the graph data, there are so many different topics, of course. Also, we have different kinds of graphs or different types of graphs we can study in the graph learning problems. So, for example, we can have either direct graph or undirected graph, depending on the direction of the edges we have in the graph. So in this part, we'll be focused on studying undirected graph instead. In other words, these edges inside the graph will have no direction at all. Therefore, if we have some data sets and the graph is directed, then we may consider to transform this graph into an undirected graph instead by removing the direction of the edges inside the graph. So for this stage, we will also have one project, and some of the graphs are directed. Therefore, you have to do removing the directions in the graph. Then you will be able to learn the representation of the nodes inside the graph data. Okay, then what is graph neural networks and what is graph embedding? So the main purpose of graph neural networks, or the GNN by short, is for learning the representation of graph data. Here, I'd like to remind you again, for all the problems we study in deep learning is to learn the embeddings. Therefore, that is also the reason why deep learning is also normally called the representation learning. So the main focus is to learn the representations or learn the embeddings of the input data. We try to compress all the input data in different formats, different types into a concise vector instead. So formally, given the graph as shown here, G covering V and E as the sets of the nodes and edges, the graph neural networks aim learning a mapping, F, to compress the nodes into a concise representation in a feature space of dimension D. So normally this D size is much smaller than the size of the node set. In this way, we can ensure the storage space will be greatly saved compared with the adjacency matrix, because we know we can represent this graph structure with the adjacency matrix already, right? Then why we need to further consider to compress them into the embeddings? The main reason is we want to save the storage space greatly. Also, at the same time, we also have some requirements for the mapping for this F as well as for the embedding vectors. We want to ensure the input features and the graph structure can be preserved and recovered based on the learning representations. Also, depending on the task we are studying, we also have some extra requirements for the mapping and also for the embeddings. And depending on the task, we are studying for the applications. So the main purpose for the graph neural networks is to learn the embeddings of the graph data inputs. We want to learn the embedding for each node inside the graph to compress them into a feature space as shown here.